to start by learning how to name ionic compounds. We're going to go through how to name the 3 types of compounds, and then you're going to have another video that's going to show you how to write formulas for the type of compounds. So you have the rules for naming ionic compounds. Here we're just going to do a few examples. If you notice, the numbers are the exact numbers on your worksheet. So we're going to look at the name, and first we're going to tell that it's a binary compound because there are 2 capital letters. That tells us right away that this is a binary, which means there is not a polyatomic ion in it, which means you do not need to use the flip side of your periodic table. So I'm just going to follow my naming rules, and I'm going to look at what I have here. And again, we're working on number 9. So I'm going to first see that I have Cr. I'm going to find Cr in the periodic table, and I'm going to see that the name of Cr is chromium. I'm also going to notice that chromium is in the dungeon, or in the D block. It's in that middle block. So that means I have to go in the back of my periodic table and check to see if it has variable charges. And when you go on the left-hand side, you see that there are 2 possibilities that chromium can be. And remember, if the element has Roman numerals on the chart, it needs to have Roman numerals in your name. So the way you tell what Roman numerals to put is you have to look at the chart. So I look here and see that fluorine is with chromium. Fluorine is in group 7A. So at the top of 7A, you see that all 7A elements have a -1 charge. Since there's a subscript of 2, I know there are 2 total fluorines, which means the total charge on the fluorines is -2. Since there is only 1 chromium, I know that the charge of chromium must be +2, because when it's added to -2, it equals 0. So I know that I have chromium 2, and the way I show that is by putting a Roman numeral 2, which just looks like 2 straight lines, in parentheses. Remember, you only put Roman numerals if there's Roman numerals on the name in your sheet. Then I look at the second element, which is fluorine. It is not a polyatomic, so the fluorine becomes fluoride. Unless it is a polyatomic and on that chart it has an ending of an 8 or an ite, every ionic compound, the second element needs to end in IDE. So the name of that is just chromium 2 fluoride. Notice the subscript doesn't really matter for ionic. The only way you're going to use it is to figure out charges. If I look at the next one, number 11, I'm going to again have a binary because I have 1, 2 capital letters. I'm going to look up and find that Pb is lead. Lead is also in the dungeon. So again, I'm going to look on my paper and see that lead, yes, lead has Roman numerals after it, so I have to put Roman numerals after it in the name. Again, I'm going to find that oxygen is in group 6A, and 6A elements have a -2 charge. Since there is no subscript, I know the only charge is -2. That means lead has to be +2 for these to be added together to get 0. So in the name, I know it's going to be lead 2. That goes in parentheses. And then to say the oxygen part, again, it's just a regular element. So oxygen becomes oxide. And your ionic name there is lead 2 oxide. For this last one, if you notice, I have 1, 2, 3 capital letters. So immediately I know this is not binary. I'm going to have a polyatomic. And for the most part, the polyatomic consists of the last 2 letters here. So for the first part, Ga, it's very simple. I'm going to look on my chart and figure out that the name of Ga is gallium. I'm just going to copy that down. Gallium is not in the dungeon, so I don't even have to check to see if it needs Roman numerals. And then since I know the polyatomic is NO2, right there, NO2, I'm going to look up the name of NO2 on the back of my periodic table, and I'm going to copy down exactly what it says. And the name of NO2 is nitrite. So the name of that is gallium nitrate. Make sure you're paying attention because there is a nitrate, but this one is NO2, not NO3. The next kind we're going to show is naming covalents. Covalents are a little easier. There are no polyatomics with covalents. There are no Roman numerals with covalents. So the general skeleton of naming a covalent compound is you name the entire first name, so the entire name of the first element, and then the root of the second element plus IDE. Every covalent compound ends in IDE. So I'm going to look and I'm going to say, okay, P is phosphorus, so I'm just going to write that entire first name. And F is fluorine, which goes to fluoride. And then the difference with covalence is these prefixes matter. Because what you're going to do is you're going to look at the prefix, the subscript on each element. You're going to look up the prefix on your chart, and you're going to add it to the name. The only exception is, like right in this case, there is a 1 for phosphorus. It's mono. The name should never start with mono. So if you have a 1, you just ignore it. So I'm just going to leave it as phosphorus. And then I'm going to figure out that 5 is penta. So I'm going to add that to the front of the name. So the name is phosphorus pentafluoride. The other way you can look at doing this is we know the name, like in 49, we know phosphorus and sulfur. What I'm going to do right next to this, I'm going to say, okay, if it's a 4, I know the prefix is tetra, and a 5 is penta, and that way I can write the name all across. So I'm going to do tetra phosphorus, remember the whole name, and then it's going to be penta sulfide. Remember, it's the whole first name, root of the second name plus IDE, and then you add the prefixes. So if I look at the next one, it's selenium, and there's only 1, so that would be a mono, but I know I'm not going to write that. And 6 would be a hexa, so this one will be selenium hexafluoride. So that's covalent. You're going to have no polyatomics, no parentheses. It's just going to be prefixes and the names. And then finally, to name acids, one thing we're going to notice about the acids is it's going to start with an H. And the little trick or the little sing-song you're going to remember is no O hydro. The key to naming acids is all about whether or not it has an oxygen in it. If it has an oxygen, you name it differently than if it doesn't. So for example, 81 and 86 are two opposites. 81 has an oxygen, 86 does not. If it has an oxygen, you pretty much kind of ignore the H. You don't name it at all. So really I'm just going to concentrate on the NO3 part. So to name an acid with an oxygen, I locate the name of the polyatomic, which I know NO3, when I look on my chart, is nitrate. The ending of the polyatomic tells me the ending of the acid. So an ATE ending turns into an ic. So this is going to be nitric, and then it always has acid at the end. If it happened to be NO2, nitrite, that would be nitrous acid. If I look at 86, 86 does not have an oxygen. Remember, no O hydro. If it does not have an oxygen, the name starts with hydro. You take the root of the anion and add IC this time. So it's going to be hydrobromic acid. If it's binary, if it does not have an oxygen, it always ends in ic. Look at 88. Again, it has an O, so we ignore the H. I find PO4, and the name of PO4 is phosphate. Again, ATE endings turn into ic, so this is going to be, now, the way you would really write it probably is like that, phosphic acid, but that sounds a little weird. So some of these you kind of name differently just because they sound better. So the more common name here would be phosphoric acid. So really, if you say them out loud and listen to yourself say them, it kind of gives you a hint of how you would name it and how it would sound. I wouldn't take off if you put phosphic acid, but phosphoric just sounds better. So the next video you're going to watch is going to tell us about how to write formulas.